Okay, here's an answer for January 2014, and this is question 15 now. Ph04 question 15. Right, so having read the question, it's about a defibrillator, and the first question asks us about how much charge will be on the capacitor. Well, let's have a look. So the obvious equation to use here is one you'll find on the paper, which is Q equals CV. All we have to do is to put the numbers in, 150 times 10 to the minus 6, multiplied by the potential difference across it, which is 1200. Now that will give us a total charge of 0.18 coulombs. Don't forget the unit there. Right, moving on. Now we need to calculate the energy stored on that capacitor. Now if you look at the back of the paper, you won't find this equation here. You won't find W equals a half CV squared. You'll actually find W equals a half QV, which is rather more difficult to use. If you remember this one though, you can take a shortcut. So we've got again the 150 micro, so times 10 to the minus 6 farads, times the potential difference of 1200 squared, and all together that gives us 108 joules. Again, don't forget the unit. Moving on to this one down here. When the when the capacitor discharges, there's an initial current of 14 amps in the chest of the patient. Show that the electrical resistance is about 90 ohms. Well, I could just simply use Ohm's law there, I think. So again, it's 1200, 14 amps of current, and that gives me, let's see, something around about I've got 85.7 ohms. Could be that I've written that down incorrectly from the calculator, but you can check it. Good enough for me though. That's how you do it. It's 90 ohms. Moving on to the last question for this one. Okay, now this is a written question here. 3 marks. Oh no, sorry, there's 2 more questions. Right, okay, so calculate the time it will take for 3/4 of the charge on the capacitor to discharge. Now clearly this is going to be something to do with this equation here, this exponential decay equation. We're asked for time, and we're asked for 3/4 of the charge. Now there's a quick way of sorting that out, but as we want a time, I'm just going to quickly rearrange that. So rearrange it to be Q over Q0 equals, then take natural logs of both sides. So I know that was 2 steps, but you should end up with, I think this is by far the easiest way of doing it. Okay, so if we rearrange this for time now, we'll get minus RC natural log of Q over Q0. Right, here comes the trick. So minus RC, so minus the resistance, I'm just going to use the 90 multiplied by the capacitance. Now we take the natural log of 1/4. Why do we take the natural log of 1/4? Because actually it doesn't really matter what is falling to 1/4. So if we started with a charge of 4 coulombs, then it would be down to 1 coulomb. The actual natural log doesn't make any difference. And by the time you've calculated that, you get 0.0187 seconds. And I guess as everything else is pretty much in 2 significant figures, we should do the same here. And that final written question. Oops, get rid of that. There you go. this final written question. So if the body resistance of a person was lower, the initial current would be greater. Yeah, that kind of makes sense, doesn't it? State how this lower body resistance affects the charge passed through the body. Well, the charge will be the same. Because the capacitor isn't going to store more, it's just discharging the same amount of charge quicker. So if I put here discharges quicker, then that makes absolute sense to the examiner. I hope so anyway. There we go. Right, there's another one answered.